trade-offs between sustainable development and economic development and trying to get people out of poverty. So there's a huge polarization in the country between the rich people and the poor people. And unfortunately, over our entire sort of generations, our electricity is generated by coal. 95% of our electricity comes from coal-burning power stations. And as a result, this is a very common picture in the South African landscape. You've got these cooling towers, you've got these huge coal-burning power stations, and it's causing a lot of transformation in terms of the changes in the terrestrial biodiversity and human health. And even though the pressure is on South Africa to reduce the coal, and we have made a relatively large contribution in Paris, but it's not enough. Just like in Chile, it's not enough either. But in South Africa, we will probably not meet it because the government is absolutely fixed to coal. Even though we've got fantastic solar in the country and all those other things, it's a politically driven agenda, and we just burn coal and more coal. So my studies are around impacts of the sulfur and nitrogen from those coal power burning stations on the system. So what are we very concerned about is these, as I said, all of these emissions, all of these in a very small area. We have 13 power stations, and the local meteorology is in the winter time completely conducive to trapping all of those emissions over a very small area. So we understand the meteorology well, but we are very concerned about the acid deposition because it's a farming area, it's a forestry area, it's a natural vegetation area. So there are lots of different land uses and also the human health concerns. So as I spoke to you yesterday, when in the type of research I do, we do kind of systems analysis. We try and measure everything on a research platform so we can make the links between the various aspects. So just like some of the pictures that we've seen over Santiago, what happens in South Africa down here is this is South Africa, and this is where all the power stations are. And during the winter time, which is June, July, and August, we get this very stable circulation, and occasionally it recirculates for a significant amount of time, and then it blows out into the Atlantic Ocean, and then it cleans out into the Indian Ocean, and some of it goes north. And then at other times of the year you have the major flow going out into the Atlantic and a smaller flow going out into the Indian. But the bottom line is it recirculates significantly before it gets cleaned out to the ocean. So we are very vulnerable to deposition. So we've had a number of campaigns, and our first one was called Safari, because that was focusing on the links between fires and atmospheric chemistry. So the Safari program stood for the Southern African Fire Atmospheric Research Initiative. You know how scientists love making up acronyms. You buy lots of beer and you sit in a pub and then you make up the names. So we focused a lot in Southern Africa on these parameters over here between June and September, which is when the fires are burning in our hemisphere. We've got studies on mineral dust, and most of the mineral dust goes off from the west side into the Atlantic Ocean, and that happens the whole year. We've got a lot of marine aerosols and pollution all year from industry and coal burning. So we've got all of those things happening simultaneously, and we've got various people studying those different processes. So this is the part of the country where I live, in this red block, and it just occurred to me yesterday that the air quality in Johannesburg, even though it's at 1800 meters, is bad. So I wake up every morning, cough, 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 cough. I haven't coughed once since Santiago, so you've got something right. And I probably won't even cough in Beijing, so we're not doing too well, okay? So we've got very good models of both wet and dry deposition in the country, and this is the sulfur deposition, and it sits here right over my house. And the rainfall pH is about 4.2, 4.1 at the moment. And then it's out here towards the eastern part of the country where there's a massive increase in deposition. So we have data for this part of the country. All of the power stations currently sit in this area here, and the Kruger National Park sits here. So we are trying to understand the impact of the transformation and then the deposition of the aerial pollutants moving from this part of the country to that part of the country. So that's the type of research that's being done. And then what's most concerning us is we are building 2 new huge power stations in this part of the country. So this part of the country is pristine wilderness, game part of country. Now we're losing that. So what we've been doing is we're looking at the moment the total deposition of sulfur in that area is 4.45. But it'll probably go up to about 50 kilograms per hectare once the power stations are in place. So they've put in a smaller power station in that area as a pilot, and they're currently constructing the biggest one. It'll be the biggest power station in the southern hemisphere, something of which I am not very proud. Okay. So we've done an analysis on the soils in this entire area of the country to have a look at what's called critical load exceedance. So in other words, remember we're similar to you in some respects in that we sit on acid tropical soils. So in certain parts we don't have a lot of nutrients, and if you're constantly putting sulfur and proton ions onto those soils, you very quickly drop the pH of those soils and they no longer become agriculturally productive. So this is the big area over here where it's now going to get more and more difficult, because these are the areas of deposition of the nitrogen and sulfur. So we are exceeding the nutrient loading or the acid-base reactions in the soil. So the vegetation in the northern part of the country is savanna, and it looks just like this. So what we call a savanna is you have indigenous natural grassland, and then you have trees, and they have different photosynthetic pathways and different C3, C12 signatures, C13, C12, etc. So it all follows along like that, and it's in here that there's a huge species diversity, invertebrates and vertebrates and all sorts of things. You know, not 2 or 3 big animals, but 400 big animals. So it's a very nice area. That's what it looks like now. So it got completely cleaned out, and this is the baby power station that they built. Okay, this is the first one, and that's been there now for 11 years. So we've got data on the soils and on the water chemistry and on the plant biodiversity prior to this power station going up, so that we can use that as a baseline into the future. So in this part of the country, which is called the Waterberg, which ironically is where some of the highest rainfall is in the country, And we are, of course, in the interests of economic production and giving everyone electricity, we are making it completely unsustainable because the waters in those areas are becoming more acid. So we're really caught. So if you have a look in this area where the sulfur emissions are coming from, you can see they're predominantly coming from power generation and lot PM10 and NOxes. So we've got those data from the past and from 2014, and we're continuing with a team of atmospheric modelers and chemists to monitor particulates as well as SO2, NOx, PM10. And this is the baby power station, this is the beginning of the bigger power station, and then the additions. Now, the kind of thing that happens in my country is that the design was approved with a very specialist type of scrubbers. So all the sulfur would be removed, all the nitrogen and noxic gases, toxic ones, would be removed. And then, of course, the government said, oh, no, I'm sorry, we spent that money on buying chocolates. Okay? So there are no scrubbers. Okay. So all of these data now is with zero flue gas desulfurization. So it's a problem. The methods that we are using are, we're doing passive sampling. What was a lovely pristine area, it now looks like that. And we collect these filters regularly for the particulate sampling. We've got specific sites along a transect, and we're just doing some simple inferential modeling for the deposition. So summer, autumn, winter, spring, and those the seasons, and we're looking for seasonal patterns in the landscape, which is linked to rainfall. And then we're also looking at whether you are upwind or downwind of these big power stations. But an overlay on that is the fact that there are we've got 29% unemployment in the country. So as soon as a mine or electricity power plant like this starts to be constructed, you get the migration of thousands of people from one area of the country to the other area of the country, hoping that they will find employment. So this town over here, this is the name of a town, it's called Lephalale, and Lephalale was the traditional old area in that area of the country that only white people could inhabit. So when the unemployed people moved into this area, they just built shacks that look like this, that sit in pollution 24 hours a day, 365 days a year. They burn fuel inside domestically so that they can keep warm. So the air quality both indoors and outdoors is absolutely terrible. And this area over here it's called Marapong, which is this informal settlement. And at the moment, the amount of deposition that we are picking up is mostly in the winter, which is when we would expect it to be, especially dry deposition. There's no rainfall, and it's when they're burning the majority of coal to keep people warm. You can run. You can run now. Okay, so we have the SOx, we have the NO2 results, same thing, looking for pattern to make sure that we have a good baseline, so that 10 years from now the students will be able to come back and say, this is where we're at, these are the concentrations, 3, 4, 5 ppms, where are we moving from here by season. So this was the vegetation, and they cleared an area about 7 kilometers away from the power station. That's what they needed, like as a security area around the power station. But beyond the power station, there are these typical thorn trees and then these grasses. Now these thorn trees have evolved over time, and they are very, very sensitive to nitrogen and sulfur deposition. So we've done field experiments, we've done pot experiments, and we've deposited 2 kilograms of nitrogen, 4 kilograms of sulfur, etc. in a multifactorial design over time. And the answer here is that these acacia trees are extremely sensitive to additions of nitrogen and sulfur, because acacia trees have root symbionts, and as soon as you put additional nitrogen on, you kill the root symbionts. So, change in tree biodiversity, probably. However, the grasses are less sensitive to these acidic conditions. So what that means from a tourism and beef producing area, it means a switch in your kind of land use. Because if you have trees and grasses, you can have goats and cattle, or you can have elephants and antelope. But if you lose your trees and you get more grasses, then you switch from animal tourism to cattle farming. So there are big sort of implications for the people in the area as to what happens. We continuing to do a study both upwind and downwind of lichens, and I know many atmospheric chemists have no idea what lichens are, and they're those funny furry things that grow on trunks of trees, or they're also found on rocks, and they're known to be the most sensitive indicator to sulfur increases. So we were collecting the lichens, so we've been working downwind of the power stations, which are potentially impacted, and upwind of the power stations to look at different species. And at the moment, there's a similar number of lichens, upwind and downwind, but it is starting to show quite dramatically that it's not the total number of lichens that actually matter on the trees, it's the type of lichen is changing as well. So when we have a look here, these crustose ones are much more tolerant of acidity and pollution. So downwind, we're finding that species dominating, or that type of lichen dominating, whereas the foliose ones, which are very sensitive, those ones are going already, and that's over a period of 8 years. So we're going to watch those. And then the last part of the work that we're doing is around humans and animals, and you know this, and we heard it this morning from Pong about increase in global premature deaths in the country. So we've been looking in these different socio-economic circumstances around people's health. So we have these very different 3 sites of different poverty levels. We have Lepelale, which is the highest social economic wealth, then a middle site, Marapong, this informal settlement, and then Steenbokpan, which are farm sites which are completely rural. They've got no electricity, they've got no running water, they've got none of those. And we've been measuring the how people perceive air pollution, how often they go to a doctor, and what are the ailments that they are suffering from. Now, people perceive that there is a level of pollution, and of course it's the highest social stratum group of people that perceive the air quality to be the worst. Okay, the poorer the people get, the less concerned they are about that part of their life, because they're hungry in most cases. And then when you actually look at the number of respiratory cases, it's the people in the informal settlements and that are visiting doctors and reporting respiratory diseases, and it's the poorest of the poor in Steenbokpan who can't even get to a medical facility. So those don't get reported at all. So in this area, it's been a very interesting way to do science, because in South Africa, with the sensitivity around HIV and AIDS, rural clinics are not required to keep medical diagnosis of who comes to the clinic for what ailment. It's an invasion of privacy. So the only thing they have to record is the number of people that visit, the gender of the person, and the age. So that's all you can get. So you can't ask, did they come for high blood pressure, or did they come because they were coughing? Okay? They don't know. They don't keep records of it. So the only way that we could keep records of it is we could, and they gave us permission, was to go back to the pharmaceutical companies that dispense drugs to the pharmacies, to the dispensaries at the hospital, and then from the type of drug that is most used in the hospital, we could then work out backwards how many cases were respiratory cases and how many were blood pressure. And so it was a bit of a devious way to get the data, but it was very clear that respiratory diseases are on the increase. And the last part of the presentation is that these areas here, as I mentioned, are important for ecotourism. So we have studied the deposition of these various species in total dry and total wet onto forested or broadleafed tree vegetation versus grassland vegetation. And these differences here have to do with the leaf area that's intercepted, and then looked at them in other parts of the world. So in the when the European forests were most polluted, they were experiencing about 79, 70, and we're at 29 and 40. So we are very rapidly heading up the bad boy trajectory, and then we do these systems analyses of what nitrogen and what sulfur is coming from what process, and we understand a natural system so that we can then, the key things into the future are going to be this number over here. So for example, wet and dry deposition, we're getting in 21.6 kilograms, and even though this vegetation burns every 3 years, all of it, we only lose 2 kilograms of nitrogen back to the atmosphere. So these systems are increasing in nitrogen in total input-output analysis, which means the acacia trees hate the nitrogen. So we will get species differences, which mean things like giraffe go out because giraffe only eat acacia species. So those are the implications. The very final bit is around an experiment into the Atlantic Ocean. You see another fun name, the Sea-Earth Atmosphere Linkage Study in Southern Africa, yay! It's called SEALS, because there are lots of seals in that area. Okay, and these are all the things that are being looked at, and it's a very typical kind of biosphere, terrestrial oceanographic and atmospheric study. So this cold Benguela current, as we saw earlier today, and the changes in the temperatures around Cape Town between this ocean and that ocean are very dramatic now, to the extent that the pilchards and the sardines and the anchovies have it's getting too warm, so they're moving around here. So the penguins can't fly or can't dive or can't swim far enough to get the pilchards anymore. So we will lose the African penguin in probably 20 years, 10 years. They're on the way out already. So there's a lot of work here on, this is the Namibian Desert, where all the sand blows off into Amazonia, and then other sites in Africa. And as I said, it's one of these typical experiments where we're doing from the land, dust deposition, transport, and we've got the NOAA plane and the NOAA ship comes out here on transects, along with a number of measurements from NASA. So that's where I come to the end, and you saw this yesterday. And for me, it's been a great pleasure to live in Southern Africa for most of my life, even though politically it has been a little tense at times. But I'm exposed to a great variety of different organisms, different diversity and interactions. So thanks very much.